Hi, it's Robin. In a previous video, we looked at this VTech PreComputer 1000 that I borrowed from my friend DJ Schurz of Naboo computer fame. It was a cheap toy computer that sold for about $70 in 1988 at Sears and other stores. We looked at all the features, the built-in typing tutor, the trivia quiz games, the math games, word games, and the fact that it's programmable in BASIC. It's actually a fun little Z80 based computer with a decent keyboard, especially compared to an Atari 400 or Timex Sinclair keyboard. And if it just had a way to load and save and a little bit bigger of a screen, it could have competed with Radio Shack's Model 100 computer at a small fraction of the price. So check out that previous video if you missed it. By the way, I'm recording during the daytime instead of at night, and my house might be a little louder than normal. Excuse the footsteps and whatever else you hear. But while working on that previous video, I started getting curious about the BASIC, which they just called PreComputer BASIC version 1. Here under the computer drill, PreBASIC version 1.0. So did VTech really invent this language for the PreComputer? Or did they borrow it from elsewhere? There doesn't seem to be any credit given in the manual or on the box or on the device itself. I'm going to try to examine it today just by using it and see if we can figure out where it came from. Kind of like a clean room examination, I guess. We won't be doing any disassembly on it, and I wouldn't even know how to dump the ROMs from this device anyway. On page 42 of the manual for the PreComputer 1000, Dartmouth and Microsoft both get a mention for BASIC, but it's presented more as a history of the language. They don't seem to give it any credit. Now, we do know that this PreComputer uses a Z80 processor, and Microsoft made a BASIC for the 8080 processor, which got used on Z80 computers as well. First, there was Altair BASIC, and then it got generalized into BASIC-80 for the various 80 family processors and the Zilog version. A variation of this ended up in the TRS-80 Model 1 computer, commonly called Level 2 BASIC. BASIC-80 has an original 8K version, then an extended version, and a disk version that was especially used on CP/M machines, I believe. So anyway, let's try a few easy tests on the PreComputer 1000 to see if they behave like a typical Microsoft BASIC or any other BASIC we've seen before. So first of all, the question mark abbreviation is supported for print, and not all BASICs allow that, but that is a feature of Microsoft BASIC and some others. Also, if we do something like print 4 is less than 5, it'll return a -1 for true, and it would return a 0 for false. If we do 4 is greater than 5, it returns 0. So that -1 for true seems a little odd, but it's actually typical of most Microsoft BASICs, except I think AppleSoft BASIC, which uses a +1, and they changed that to match the previous integer BASIC's behavior, I believe. I'm no expert on the AppleSoft BASIC, but I think that's true. We also saw last video that line 0 is supported. You don't have to start numbering at 1, which is a feature of Microsoft BASIC, and also this kind of quirk or bug where you don't actually have to specify a line number if you just want to go to line 0. So we can enter that and run that program, and it doesn't generate a syntax error. It's just an endless loop. We can break out of that here. Another interesting indicator is the maximum line number that's allowed. This varies between implementations of BASIC. Some BASICs have a max line number of, say, 999. Whoops. Others have a max line number of 32767, the maximum value of a signed 16-bit. Commodore BASIC has a maximum line number of 6399, so we can just type them in. If we get a syntax error, we'll know that we've exceeded the valid line number. Okay, so line number 6399 is fine. How about 6499? Yeah, even that's okay. Now, it shouldn't allow 65536, because that exceeds a 16-bit value. So there you go. You get a syntax error. On any BASIC, you can play around just kind of a high-low value here. Does 65,500 work? Yep. How about 6525? Yep. How about 65,530? Syntax error. How about 65529? Yes, that's okay. So here we can go 65529 highest and 65530 error. There you go. So the range is from 0 to 65529. So that's kind of like a magic number. And I didn't realize this, but this actually matches the official BASIC-80 implementation, where valid line numbers are between 0 and 65529. Another thing is we could build a little program that loops from, say, 1 to 100. And we're going to build up a string with a string plus the string value of x, that is just converting the number into a string and appending it onto the end of a string. Next. Okay, so if we run that, it gives an OS error. That's not an operating system error. That's a out of string heap space error. That is, we've overflowed the amount of space on the heap for strings. So if we look at x, you'll see it only got through 12 steps of this process. And if we print the length of a string, we'll see how long it got. So it only got to 24 characters. We should actually be able to print that as well. A string. So you see it's printed the string values up to 11. And then it failed. So that seems like the heap size is only maybe 25 or 30, hard to guess. I guess around 25 bytes. Now on Commodore BASIC, we use the clear command to clear all variables, but we won't lose the program. But it doesn't take any parameters. That's all it does is wipes out the current variables. But on this BASIC, we use the clear command spelt in full, and then we can specify the size of the heap. So we know we have 2 kilobytes total. Let's try and reserve 1,000 bytes for the string heap. Will it let us do that? Seems to have. Is our program still there? Yes. So let's try and run it and see if the program actually works. Ooh, LS error. Okay, so that's the long string or string too long error, meaning we exceeded 255 characters. So that program's just not going to work. But it didn't run out of string space, so it got up to 89 iterations. Okay, so let's just edit line 10 here. And instead of going for 100 iterations, let's just do 80. And run that again. This cursor just blinks the whole time. Did we finish? Yes. Yeah, X got to 81, which is what's expected. And can we even print a string? And it should print all the numbers here. 29. Ooh, that's pretty weird. Okay, let's print the length of a string. 231. Okay, so that's pretty interesting. If we try to print that string we generated, I guess it just can't handle printing long strings. Very interesting. Actually, as a little diversion, let's just restart BASIC here. Pre-BASIC version 1. Let's see what the maximum string heap space is. If we do clear 1000, okay, that seems to be okay. If we do clear 1300, out of memory error. And clear 1200, that's okay. And to skip, because you know I already did this, clear 1235, that's okay. But clear 1236 gives an out of memory error. So the maximum heap space is 1235. sometimes if you break it, it's done for. You're not going to be able to clear it. Even if you do like clear 50, you're just going to get out of memory errors. So you can actually break it by setting the string heap size too big. Then you have to just basically reboot it again. So that says to me out of the 2K of RAM used, the system itself uses maybe about 700 and something bytes for its own purposes for BASIC and whatever other low, simple operating system this has. And the remainder is available for the strings, variables, and your basic code. And note if you do that clear 1235, now if you try to type in any line number like print or any line of BASIC, you're just going to get an out of memory error. Okay, back on track with BASIC-80. I'm going to restart it yet again. Okay, another indicator. If I'm starting to become pretty certain that this is Microsoft BASIC based. But if we set variable AB to 5 and AC to 6, and then print out AB, AC, you'll see it'll print out 5 and 6. So AB and AC are two different variables. Microsoft BASIC, these early versions of Microsoft BASIC, allow up to 2 significant letters in the variable names. So if we rework this to go ABC equals 5 and ABD equals 6, and then we print each of those variables, ABC and ABD, and run it, you'll see that both of them equal 6 now. And that's because ABC and ABD, the first 2 letters are both AB, therefore they're actually the same variable. So what we're doing is assign AB to 5, but then right after AB to 6. And then when we print them both, that's why it's printing 6 both times, because it's actually just printing variable AB. You notice how it pauses after those commas or semicolons in the print statement. Like it prints one value, and then waits for you to hit enter to print the second value. Even though it's part of one print statement, I guess I understand because of the very limited one-line screen, that's why it's like that. It would be nice to make that optional, because this precludes the ability to make any kind of like an action game or something that continues on without constant user input. I'm not aware of any way of printing without it actually requiring enter to be pressed constantly. It'd be great if that was optional, that you could just turn that off, and it would be up to the programmer to decide what the user sees. And as I mentioned, it seems every kind of poke just gives a syntax error, peek, sys, call, all that, those all seem to have been disabled in this BASIC. Very unfortunate, because that would be a lot of fun to even just have a peek, never mind anything else, to figure out more about this computer. And also load is just not there, syntax error. And some BASICs have a C cassette load, and that also gives a syntax error, whether or not you give it a file name or whatever. Wouldn't it be great if they allowed some sort of a flash cartridge? Cartridges for this were $20 each, just ROM-based. So I don't know, maybe a $30 cartridge that just allows you to save even a few programs would be a great thing. Okay, and how about floating point variables? If we do something like A equals 9.12345, and then we print that out, you see it does print out 9.99999. Okay, now if we edit line 10, and just add one additional 9 to the end, so that's 7 digits total. We'll see now it's rounded it up to 10. It seems any 7-digit value does this. If we go A equals 1, 2, 3, 4, 5, 6, 7 nines, and we run that, it switched to exponential format, 1E plus 07. So that was a bit of a shock. I'm used to Commodore BASIC, which allows you generally to be able to do 9 digits before it switches to this exponential mode or starts rounding off. So this is quite a bit fewer digits. So that was a surprise, but this is also a feature of BASIC-80, as Microsoft's 8080 or Z80 BASIC. This Microsoft BASIC originally shipped with just single precision format, which only uses 32 bits, and it's got the nickname of 6-digit BASIC. And it was the 6502 port that we're used to on the Commodore that extended the 32-bit precision format up to 40 bits, and that gave us 9 digits, and that became pretty standard on all the 6502 machines. So we've seen some of those errors. It just says SN, so it's just 2-letter error codes, syntax error, while on the Commodore, we're used to it printing a longer syntax error message. So this is also something that's consistent with the BASIC-80 language. It just used these 2-letter error codes. Probably my favorite one is if you try to print an invalid array. So like we'll just do an undefined variable b index 100, and it will give us a BS error, which apparently stands for bad subscript. This computer called it BS. It's not taking any more of my input. I was pleasantly surprised to see that else is supported. Then print 1 else, print 0. It's just a goofy example. We'll run that, and you see 0 is printed out because a is not equal to 1. So if we edit that, so if we set a to 1 and run that, it'll print 1. But if we set a to 2, then the first part here won't be valid, and it will do the else clause here. Print 0. That's not the greatest example, is it? What is a good if-else example? I can't think of one today. So there are a few things that seem different than BASIC-80. If you try print, I think I mentioned this in the previous video, but if you try to print character string, 20, and you run that, you'll get an FC error. And if you try to do greater than 127, then you also get that FC error. They've deliberately limited the number of valid printable characters, maybe just because of the fact that it's just the single line display. It would be nice if there were some control codes that were valid or hidden characters. Another one, and this will just print a random number. If you give this basic random 0 as the parameter, it'll just give you a different random number each time. But on BASIC-80, it will actually always return the same number as last time. This does seem more useful, but if you do a number greater than 0 on this, now it should give us a random number from 1 to 9 each time. While on BASIC-80, that would just return a float just like we saw before between 0 and 1. So I don't think that proves that they made their own BASIC, but it does prove that they've modified it somewhat. I found some other BASIC-80 features that are not documented in the PreComputer manual, but are in the BASIC-80 manual, and they work on this. For example, integer variables are supported. A% equals 5. That percent sign means it's an integer, and regular single precision float is if there is no symbol after the variable name. So these are two distinct variables. Now let's run that, and we get 5 and 6 because they are distinct variables. Another interesting one is a equals 1. On A, Goto and GoSub are both supported, 30, 40, and 50. So if A is 1, it'll go to 30. If A is 2, it'll go to 40. And if A is 3, it'll go to 50. So I'll just print those out. We won't do anything too interesting here. We'll just print out 1, 2, or 3. You can use the line editor to duplicate lines pretty quickly. Oop, I forgot to change the print. Okay, so it should print 1 and then end. If I change that to 3, then it should go to the third value here, which is 50. And line 50 will print 3. So there we go. On Goto is actually a very powerful construct. And it's not mentioned in the manual, but it is available in this language, which is both good for the user and a little more proof that this is using BASIC-80. Another one is only single dimension arrays are mentioned in the manual, but Microsoft BASIC supports multi-dimensional arrays. So we can do something like, dim A 99, and it's fine with that. We can dim A 20, 2, so this will make a two-dimensional array, 20 by 2, and actually it's, because this is 0-based, it's actually 21 by 3, the array. That is 0, 1, or 2 for this index. So you see, two-dimensional arrays don't complain either. So I found I can actually dimension up to, let's see, 4, 5, 6. DD error. So that doesn't work. 2, 3, 4, 5. There. So up to 5 elements seems to work, but it's probably just starting to run out of memory if you try to do, 6-dimensional arrays with 2 kilobytes of RAM total. I'm going to reboot just in case I messed something up there. And a few other things. There seems to be some remnant left of support for double precision numbers. Some versions of BASIC-80 allow you to support double precision variables or even values. So we can do big number like printing 1E38. That means 1 times 10 to the 38. And it prints it out okay. By the way, that overflows. That's like right up near the limit. 1E39 causes an overflow error. But if you want to define it as a double precision, you can actually do that. 1D38. And there it is. She paused for a while there, didn't it? 1D38. But it actually supports double precision, sort of. Just in case you don't believe, I don't know, if we did 1F38, that's meaningless. So yeah, it parses it as 1 and variable f, which is equal to 0. So it's interesting that 1D38 is in there. The C64 doesn't support that at all. But if you actually want to define a double precision variable, you would actually use A and the number or hash sign nowadays. So like 1D38, but it gives you a syntax error for that. So the actual variables aren't supported. And if you want to tell it that a number should be interpreted as single precision, 4, 5, 6, 7, 8, put an exclamation mark afterwards, and then print it out. But it gives you syntax error. So yeah, it's clear. It's clear that single or double precision variable names aren't supported. But here's the interesting thing. You see variable A has been assigned 123.457. So even though we put that sign at the end, it is being assigned into variable A. If you want to tell it's a double precision, put the number sign after. And it still works, but it's not double precision, obviously. Kind of interesting. So there's kind of remnants of that double precision in here. And a few other things that seem to have a little bit of remnants to it. In some BASIC 80s, I think the extended one, you could assign A, and then you could do &H to indicate you want a hex number, FF. But if you run that on this, it actually gives this weird L3 error, which just means invalid error code. So it's almost like maybe there was a little bit of remnant for hex definitions, but didn't make it through here. And being able to define functions like function A, you can define it to 2 times x, oops, and then print out function A and pass it the parameter 20. Now if we run that, see it gives us a BS error in 20, but it didn't give us an error on line 10. Even though we defined a function, you'd think that if this was totally invalid, it would give a syntax error here, but it just ignores it or whatever. But then line 20 causes a BS error, and I think that's because it's interpreting A not as a defined function, but as an array that we're passing, that asking for index 20, and that's a bad subscript because we haven't defined an array with 20 elements. Okay, so I'm basically sure that this is BASIC 80 derived. I don't know if VTech had the source code to some version of Microsoft BASIC 80, if they licensed it, if they hacked the binary. It seems like a very elaborate hack to remove so many commands, enhance some, add the sound command. If they didn't have the source code at all, that's not impossible, but maybe they did have the source code. Maybe they even licensed it. I don't know. It's just strange that there was no acknowledgement. I thought Microsoft would require that, but maybe by 1988 they didn't care. Okay, do you have any other ideas how we can examine this? And maybe some of these techniques we looked at today could be applied to other systems. Okay, thanks again to DJ for lending this PreComputer 1000 to me. Oh, there it is. If you haven't already, check out DJ's channel about Naboo and other stuff. And this PreComputer will probably show up there in a future video of his. Okay, thanks to my patrons for their support. Thank you for watching, and we'll talk to you next time.